What is time even?
What is time?
The time.
Time.
Time. What then is time?
Oh, it's nothing.
In 1972, French geologist Michel Sifry lived in a cave in Texas for 6 months. The experiment was conducted as part of a NASA project aimed at studying the effects of prolonged isolation on the bodies and minds of participants in future interplanetary expeditions. Sifry settled in a cave deep underground, where he was supplied with water and food, and equipment was installed to monitor his sleep patterns. Throughout the experiment, the lighting and temperature in the cave remained constant. Sifry had no clocks and no way to determine the time, how much time had passed, or even whether it was day or night. He lived in a free rhythm, waking and turning off the lights in the cave at his own discretion. People generally do not cope well with such experiments. Sifry suffered from bouts of depression, memory lapses, forgetfulness, and even contemplated ending his life. But the most interesting aspect was what happened to his perception of time. In the first days, his days stretched to 25 to 26 hours, which is unusual. However, this was just the beginning. Gradually, Sifry's subjective day, when he was awake, reached 32 hours, and the night, when he slept, lasted 16 hours. Thus, sometimes his days reached a total of 48 hours, which is twice the normal length. On the 179th day, Sifry was informed that the experiment was over, and he was very surprised because he believed he had been in the cave for only 151 days. This means his internal sense of time had slowed down compared to real time to such an extent that he was off by 28 days. And this is strange. It would be one thing if he had been enjoying himself, but to underestimate the passing hours when you are going mad alone in a cave. However, this form of subjective time dilation has been observed in many other similar cases of human isolation, sometimes in an even stronger form. In 1988, Véronique Le Guin lived in a cave in France for 111 days, and when she came to the surface, she thought only 42 days had passed. In 1989, Italian interior designer Stefania Fellini spent 4 months in a deep cave, but she believed she had been underground for only 2 months. These cases vividly demonstrate that our subjective perception of time is unreliable. You might argue that, like any subjective experience, subjective time is a product of brain activity and does not exist outside the human skull. Just as, for example, color does not exist in nature. Color is merely the brain's interpretation of a narrow spectrum of electromagnetic waves. There is as much in common between them as there is between letters of the alphabet and the sounds we assign to them. And, of course, like most subjective sensations, the sense of time is susceptible to illusions and distortions.
What then is time? If no one asks me, I know. If I want to explain it to a questioner, I do not know.
St. Augustine. And physicist Richard Feynman said,
It would be nice if we came to terms with the fact that time is one of those things that we probably won't be able to define. What really matters is not how we define time, but how we measure it.
So, the working definition literally sounds like this: time is what clocks measure. However, if we attempt to answer this question in more detail, most people would intuitively conclude that time is a sequence of events flowing from the past to the future through the present. Only the present moment is real, as each moment that passes into the past simply disappears, and the future has yet to occur and therefore does not exist yet. In fact, the past and the future are just our abstractions. But modern physics unequivocally suggests that the actual picture of the world is quite different from this description, and that whatever time may be, our intuitive understanding of it is seriously flawed. Many do not realize just how flawed it is. Let's consider a thought experiment that everyone has heard about in some form or another. It has become so overused that we have stopped paying attention to it, let alone trying to think about the paradoxical conclusions it might imply about reality. I'll describe it quickly. Imagine a strange train with a single car 400,000 kilometers long, moving in a straight line at a speed of 200,000 kilometers per second. A person is standing exactly in the middle of the car. He has a gun in each hand. One gun is aimed at the window at the front of the car, and the other at the window at the rear. These guns are so powerful that the speed of the bullets fired from them is 200,000 kilometers per second. When the person in the car fires, both windows will break exactly 1 second later, and this will happen simultaneously. This seems obvious. However, if at the moment of firing, the person in the car is aligned with a person on a stationary platform, the person on the platform would see something different. The bullet fired backward would also break the window after 1 second. Its speed relative to the train would be 200,000 kilometers per second, and 0 kilometers per second relative to the platform. This is perfectly legal. But the bullet fired forward moves at 200,000 kilometers per second relative to the car, and at 400,000 kilometers per second relative to the platform. From the perspective of the person on the platform, this is the speed it needs to reach the front window in 1 second. However, we know that 400,000 kilometers per second is an impossible speed, being 100,000 kilometers per second higher than the speed of light. Therefore, due to the effects of special relativity, the time for the bullet will slow down, and according to calculations, from the perspective of the person on the platform, its speed will actually be only 277,000 kilometers per second. Consequently, from the viewpoint of the person on the platform, it will not reach the front window in 1 second. The windows will not break simultaneously, the rear window will break first, and the front window will break later. This is not a trick of the eye, it is an objective fact. Special relativity has been tested in so many ways and with such astounding precision that we can say with certainty, if the described experiment were conducted in reality, this is exactly how it would play out. This phenomenon is called the relativity of simultaneity, and it tells us something absurd about the world we live in. It seems as if we have two different realities. In one, both windows are either simultaneously intact or simultaneously broken. But in the other, there is a moment when the rear window is already broken while the front window is still intact. These are not two separate universes. Both individuals are in the same universe because, if they were to talk to each other, they would disagree about when the windows broke. So, which reality is real? As strange as it may seem, special relativity tells us that both realities are equally valid. But how on earth, should the universe look for this to be possible? Contradictory statements cannot both be true simultaneously. This violates the laws of logic. The world doesn't have to be logical, but we must at least try to depict the reality we inhabit. Well, attempts have been made for over a century, and they have yielded results. The model of the universe that I will describe today once again has nothing to do with our everyday intuition. However, this model is accepted and considered accurate by a vast number of physicists and philosophers because the laws of physics point to it. Honestly, it's not very comforting because, as you will see, the picture is rather bleak and unappealing. Although, it might depend on how you look at it. And yes, the most complex mechanism known in the universe, located in our skulls, did not evolve to understand the nature of time. But the contradictory picture of the universe that will be revealed to you has likely left some imprint on the very construction of the human brain. As we will see, its structure, along with the laws of physics, hints at the nature of reality. Science always tries to separate the experiment from the experimenter to achieve maximum objectivity, but the author of the book Your Brain is a Time Machine, Dean Bonamano, tries to do the opposite. And he doesn't succeed. Because what seems familiar and natural to us is drastically different from what the equations tell us. For over 100 years, scientists have been striving to find something in the physical world that could be called the flow of time. So far, in vain, and thus Bonamano, like many before him, concludes that perhaps the human perception of the passage of time is nothing more than an illusion. First, we must discuss what time means for us, humans, to, on one hand, better understand the madness of the second half of the discussion, and on the other hand, see that perhaps it is not so mad after all. Let's start with the fact that despite the inaccuracies in time perception that occurred with people in isolation, this is an unnatural situation for the human body. You have heard that we have internal clocks. More than that, you feel them. You roughly know when the traffic light will turn green or when the TV commercials will end. But have you ever wondered how these clocks look and where they are located? According to Dean Bonamano, temporal processing is so essential for brain function that timekeeping mechanisms are embedded in the brain's operating systems at the most basic level, at the level of neurons, synapses, and networks. It makes no sense to look for which part of the brain determines time because, in one form or another, most neural networks perform this function.
If someone needed to put the essence of brain function in a nutshell, perhaps the best definition would be foresight of the future.
Let's start with the fact that the brain is, in the broadest sense, a time machine. Not in terms of time travel, but in terms of dealing with time. For hundreds and hundreds of millions of years, animals on Earth have competed to develop the ability to predict the future. Predators learn to anticipate the behavior of their prey, and prey learn the behavior of predators. And all of them try to predict the behavior of potential mates. Some prepare for the future by storing food, building nests, and screwing down jars of jam and pickles. Life on Earth senses sunset and sunrise, winter and spring. Those who didn't cope with this didn't survive and didn't leave offspring. And whether you realize it or not, on a moment-by-moment basis your brain is automatically attempting to predict what is about to. These short-term predictions, up to a few seconds into the future, are entirely automatic and unconscious. ISO bouncy ball rolls of the table, we automatically adjust our movement to catch it off the bounce, which we do not do when a muffin falls off the table. Humans and other animals are constantly trying to make predictions over various time periods. Bring a cat into a new home and observe how it meticulously builds a mental map of the territory, sniffing every corner. This prepares it not only for what might happen in a few seconds, but also in a few minutes or even hours. When a wolf pauses to catch signs, sounds, and smells, it seeks clues that help detect potential enemies, prey, or mates. When a chameleon catches its prey with its tongue, it needs to know where the insect will be in a second, and this again requires the ability to predict. Pollinating birds measure the time elapsed since their last visit to a specific flower, ensuring the flower is refilled with nectar by their next visit. Literally all manifestations of life, from the ability to hit a moving target with a spear, to knowing when to laugh at the end of a joke or play Beethoven's Moonlight Sonata, to regulating the daily sleep-wake cycle or the monthly menstrual cycle, all of this requires the ability to determine time. The brain doesn't just count the seconds, hours, and days of our lives. It recognizes and creates temporal patterns, such as musical rhythms and precise sequences of movements that allow a gymnast to perform acrobatic tricks. Our natural inclination to clap hands, snap fingers, or nod our heads in time to music further illustrates that the human brain is constantly engaged in prediction. Your brain peers hundreds of milliseconds ahead, predicting the next beat and synchronizing your actions with it. If you want to understand how deeply ingrained this is in us, try disrupting the rhythm of music by snapping your fingers randomly. It requires total concentration, whereas maintaining the rhythm of music requires almost no focus at all. Contrarily, the brain detests unpredictability. Perhaps humans are among the few creatures on the planet, if not the only one, capable of mental time travel. And most importantly, the brain literally creates the sensation of time, the feeling of the continuous present moment. You can easily verify this. Conduct an experiment. First, ask someone to stand in front of you and alternately look at your left and right eye. You'll notice the person's eyes move as expected, and this movement takes some time. Then, approach a mirror and try the same with yourself, looking at your left and right eye. You'll find that your reflection doesn't move its eyes at all, not even attempting to. This is because the brain simply cuts out that moment. It does the same for every moment when you shift your gaze from one object to another. We don't even notice this, the picture appears continuous to us. The same happens when blinking. The brain stitches together frames before and after closing the eyelids. You might say these are just small things, but, for example, at a speed of 100 kilometers per hour, during the blink of an eye, a car travels about 5 meters. 5 meters that simply do not exist for you. And it's understandable, we haven't evolved to make decisions in such conditions, which is why driving in the city is so dangerous. Formula One drivers, where speeds exceed 350 kilometers per hour, actually train themselves to blink only on specific parts of the track. Overall, we lose about an hour of edited material per day. So yes, the illusion of a continuously evolving reality is the brain's doing. But the only thing we truly experience directly is the present moment. And in reality, we can only be in now, no other moment. And simultaneously, when we try to grasp this very now, it immediately slips away. But not for everyone. There's one person with a rare specific brain injury, causing his present moment to be about 40 years ago, in a sense, frozen. I'm talking about the British music critic Clive Wearing, who, after a severe infection and hippocampal damage, completely lost the ability to form stable new long-term memories. It's one of the most severe cases of amnesia in the world. His memory of events lasts from 7 to 30 seconds. His life consists of waking up every 20 seconds on average, resetting his consciousness when his short-term memory expires. And for almost 40 years now, it seems like he just recently emerged from a comatose state. If he's engaged in a conversation, he can answer questions, but he can't stay in the context of the conversation for more than a few sentences. Waring was advised to keep a personal diary, which he did. But looking inside, we personally see a horrifying picture.
And so he would write down 10:06 awake first time. And then have the same sensation and put 10:07 awake first time, truly awake first time. Ignore the last entry. Now I'm awake. This is the first real awakeness.
Examining his diaries, we see that at some point he starts writing the time in large digits, as if trying to mark himself in the continuum to reach the time belt. Isn't this a little death every few tens of seconds that he desperately struggles with? The inscription in huge letters, "I am alive." And every time he didn't know who or how the previous entries were made, although he recognized his own handwriting. Since Waring can't understand where he is or how he got here, the only possible interpretation for his brain is that he just woke up. An endless loop of one single moment. And if you're wondering what it might feel like, in a 2005 documentary, Wearing answers such questions.
You're the first 4 people I've seen in, 30 years? And if you're unconscious, you don't like it much, do you?
What does being unconscious mean?
Same as death. No difference between day and night, no thoughts at all. Day and night the same.
Do you miss your old life?
Yes. But I've never been conscious to think that. So I've never been bored or upset. Never been anything at all, exactly the same as death. No dreams even. Day and night the same.
This is a tragic story that, although it doesn't prove it, still suggests that perhaps for people, the moment we call now is connected to short-term memory and occurs not continuously, but in jerks, having a certain duration over time. Well, in other words, the conscious perception of the present can be more likened to a musical note than to a frozen movie frame. Neuropsychologist, linguist, and honorary professor of psychology at Harvard University, Steven Pinker, noted,
Matter is spread out in space, but consciousness exists in time, and this is as obvious as what I think implies I exist.
However, then the question arises, how densely is consciousness distributed in time? In what sense can we perceive a brief moment? Our sense of time changes significantly under the influence of psychoactive substances. One of the founders of modern psychology, William James, wrote,
In hashish intoxication, there is a curious increase in the apparent time perspective. We utter a sentence, and here the end is reached, the beginning seems already to date from indefinitely long ago.
The active component of hashish or marijuana's tetrahydrocannabinol, or THC for short, indeed, according to experimental data, induces a sensation of slowing down or stopping external time. In one of the early studies, people were simply asked to report when 60 seconds had elapsed after a signal. While in a sober state their estimates were close to 60 seconds, after ingesting THC orally, people perceived time differently. Approximately after 42 seconds, they believed that a minute had already passed. However, substance intake is not the only scenario where people feel the slowing of time. We have heard about this many times, and some have even experienced this effect in moments of intense emotional shock and life-threatening situations. The reasons for such time distortion remain largely unclear. There are various hypotheses, and the author suggests 3 in the book. The first is brain overclocking, analogous to increasing processor speed. Buonamano suggests that theoretically, through certain mechanisms, the brain can temporarily increase its efficiency by 10 to 20%. The second hypothesis is hypermemory. Its essence is that people perceive events in a slowed-down rhythm not at the moment of the event, but later, recalling it in memory. Thus, during a fight or flight response, the brain may enhance the temporal and spatial resolution of memory. In other words, the perception speed of events is more or less normal in this state, but the series of memories can be more detailed than usual. Therefore, in retrospect, it seems that everything happened in slow motion. The question is how much we can trust such memories. It is well known, for example, that victims of serious crimes often make mistakes in suspect identification. Of course, the hypermemory hypothesis cannot explain why people act faster and more clearly than usual in extreme situations. Nor can it explain the widespread belief that the time dilation effect is observed precisely at moments of danger. The author of the book unwittingly had to test this hypothesis on himself. He writes, In an automobile accident, my car was struck from the side, spun around, and slammed into a telephone pole. My distinct feeling during the event was not only that the car was spinning slowly, but that I thought as this transpired, wow, time really does slow down. But to emphasize that perception is far from perfect during such moments, I do not remember reacting quickly in any way or even registering that the side airbags deployed. Nevertheless, the fact that I remember thinking time slowed down would suggest that I did perceive events unfolding in slow motion during the accident, and thus that the hypermemory hypothesis cannot fully account for the slow motion effect. Therefore, he proposes a third and most intriguing hypothesis called meta-illusion. Now, if you will, I'll ask you to do something strange. Touch some object, say, a wall, a table, or a phone, and observe your sensations. Doesn't it seem strange that although the sensation of the object forms in the brain, we feel it not in our head? No, this sensation literally transfers to a specific point in space. Buonamano writes that upon reflection, this is quite astonishing. One of the deepest subjective sensations a person can have is that your fingers, hands, legs, your entire body belongs to you. And all of this is one big illusion. You've probably heard of the phenomenon known as phantom limb syndrome. If not, its essence lies in the fact that some people, after the amputation of a limb, continue to feel it just as distinctly as most of us feel a real one. This phenomenon suggests that the brain works so hard to create the feeling of owning the bones, muscles, and nerves that make up our limbs, it continues to maintain this illusion even after these limbs disappear. Thus, one can conclude that it is not the phantom limb that is an illusion, but the feeling of owning real limbs. In reality, it gets even more interesting. If you accidentally hit your finger with a hammer, the brain will project the sensation of pain to a specific area in space, your finger. But if you place an artificial hand next to your real one, the brain can alter perception in such a way that you feel your hand where the artificial one is, as if the brain agrees to consider the artificial hand as your own. This is the so-called rubber hand illusion. So based on this example, Buonamano hypothesizes that since our brain constructs such persistent spatial mirages, why wouldn't it construct temporal ones too? As you'll find out today, what we call the passage of time may turn out to be an illusion. Hence, the hypothesis named meta-illusion implies that the slowing of time itself is an illusion within an illusion. On YouTube player settings, there's an option to choose the playback speed of videos. You can speed up or slow down a clip by 2 times and still perceive information well. Buonamano writes that our normal sense of time is a mental construct that can actually have different speed settings. Again, you can test this by watching a video at double speed for 5 minutes and then switching back to normal speed, noticing how sluggish regular time flow seems. In some simulation, you'd quickly get used to living in a somewhat accelerated world and soon perceive this time flow as normal. Therefore, the author of the book suggests that the speed of our time perception is not a static illusion. In reality, we constantly use our ability to compress and stretch time. It's been proven that the brain can perform actions at a higher speed than in reality. For example, you can mentally say any phrase much faster than using your lips and tongue. The same applies to tying shoelaces, getting up from a couch, and anything else. Regarding the distortion of time in life-threatening situations, the book provides several examples. Here's what a 23-year-old race car driver said after being involved in an accident at 250 kilometers per hour, causing his car to flip several times in the air and detach from the ground to a height of 10 meters. It seemed like the whole thing took forever. Everything was in slow motion, and it seemed to me like I was a player on a stage and could see myself tumbling over and over in the car. It was as though I sat in the stands and saw it all happening. This is what a 21-year-old university student involved in a serious car accident reported. During all of this, time stood still. It seemed to take forever for everything to happen. Space too was unreal. It was all very much like sitting in a movie theater and watching it happen on the screen. And finally, the memories of a soldier from the time of World War II, whose vehicle was blown up by a mine. I had no realization of time passing, only of the moment, which never altered. Neither did I have any concept of space, since my existence seemed only mental. As we can see, in critical situations, not only does the perception of time change, but also the perception of space. Many people in such moments observe what is happening as if from the outside. Here is what Buonamano writes.
Indeed, in any other context, the above reports would be called hallucinations or altered states. Perhaps the sudden flood of endogenous neurochemicals elicited by the fight or flight response overload the brain's circuits and induce hallucinations. So maybe the slow motion effect is best considered another type of altered state, more divorced from reality than attached to it.
But he emphasizes further that the 3 hypotheses listed are not mutually exclusive. Overall, time perception is a very strange thing. We can overestimate the amount of time we spend waiting in queues or for a phone call by up to twice the actual duration. That is, every minute feels like 2. On the other hand, research shows that when listening to music, waiting time seems shorter. Companies exploit this phenomenon, which partly explains why you hear music when waiting for an operator, for example. So, to a certain extent, people can slow down or even speed up their experience of time. But what possibilities for scaling will emerge if we start to talk about time not as something we perceive, but as a physical process? If we begin to divide time into smaller and smaller intervals, will we ever encounter a fundamental unit of time that cannot be further divided? Hours, minutes, seconds, milliseconds, none of these seem to be it. Perhaps a nanosecond or femtosecond. In some physical models, the smallest discrete indivisible unit of time is called a chronon. And indeed, clocks are the most accurate instruments we have ever built. In a sense, humans have become somewhat obsessed with mastering the measurement of time. Centuries ago, clocks rarely synchronized with each other, unlike our time today. According to Einstein's general theory of relativity, time measured by any clocks is influenced by gravitational forces. Therefore, the same atomic clocks will tick faster on a space satellite than on Earth. But consider this, the readings of the 2 most modern atomic clocks will diverge if one is placed on the floor and the other on the table. Can you imagine that? Once Richard Feynman said that due to the effects of relativity theory and time dilation, the Earth's core should be noticeably younger than its crust. He estimated a difference of a few days, but recent calculations have shown that over the entire existence of the Earth, the core has aged about 2.5 years less than the crust. So, from our perspective as people living in 2024, the core is still in 2022. At present, we have learned to measure time so precisely that many quantities are defined through it. For example, defining a meter literally sounds like the distance light travels in 1/299,792,458 of a second. The progress in measurements is simply astonishing. However, despite this, science still does not have an answer to the question of whether time is discrete or continuous. Many experts agree that the existence of individual moments would lead to paradoxes, akin to Zeno's paradox of dichotomy, the modern formulation of which states, to cover a distance, one must first cover half the distance, and to cover half the distance, one must first cover half of that distance, and so on infinitely. Thus, motion never begins. Similarly, if every action takes a certain number of moments to complete, and each moment takes time to finish, we could face an infinite chain of moments needed to complete an action. Therefore, the flow of time might never even start. This is part of the time puzzle that we are gradually approaching. Here, in my opinion, begins the most unpleasant half of the video.
For us believing physicists, the division into past, present, and future has merely the meaning of an albeit obstinate illusion.
You've probably heard many times that the laws of physics are symmetric with respect to time, that they don't assign any special significance to the direction of time or any particular moment. For them, the past, present, and future are equivalent. Thus, now on the timescale is the same as here, in the realm of space. For this reason, many physicists and philosophers believe that any moments on the timeline are equally real. However, this detail, while not the most serious argument in favor of, say, Alexander the Great being just as real and existing in the same sense as you and I do, is overshadowed by Einstein's theory of relativity. The example with the train from the beginning of the video demonstrates that each observer, depending on their speed and direction of motion, has their own independent concept of the present moment. Each has their own set of simultaneous events that may not necessarily be simultaneous for other observers. This is where my mind was blown away. The effects of relativity theory illustrated by the train example sound impressive, but they are extremely disconnected from our everyday reality. In our daily lives, we don't encounter such mind-bending trains. So why should we care about this? How could it possibly affect our perceived view of the world? To understand, let's delve a bit further. The Emperor's New Mind Concerning Computers' Minds and the Laws of Physics, Nobel laureate physicist Roger Penrose presents a thought experiment that forces you to reconsider your own perceptions of reality. Even at very small relative velocities, changes in chronology become not only noticeable but also colossal. If 2 points are separated by vast distances from each other, say, 2 people slowly passing each other on the street, they won't perceive any difference in the events happening around them. But if one person goes back, and at that moment we were to teleport to the Andromeda Galaxy, which is about 2.5 million light-years away, not much in cosmic terms, the simultaneous events as perceived by these 2 passers-by would suddenly be separated in time by several days.
For one of the people, the space fleet launched with the intent to wipe out life on the planet Earth is already on its way, while for the other, the very decision about whether or not to launch that fleet has not yet even been made.
If this happens, it has the most dramatic impact on our understanding of time. And I'll remind you, the special theory of relativity has been tested with unimaginable precision. Here's an important clarification. Neither of the passers-by can actually see or in any way know what's happening in the Andromeda Galaxy, because light from Andromeda, like any information, will reach Earth only after 2.5 million light-years. The argument is not about that. It's about if we could make simultaneous 3-dimensional snapshots of the universe for each of the 2 pedestrians, these snapshots at the moment of their meeting would be almost indistinguishable, but would start to differ more and more as they move away from that point. Another crucial point, this situation applies not only to conscious observers but to any material point. Whether it's people passing each other, rocks, moving particles, or anything else, each has its own reference frame and set of simultaneous events. So, as you can see, a paradox emerges where returning to the pedestrians, 2 people who, from their conscious perspective, are at the same place and time, suddenly have different sets of events in their so-called present moment. Again, these are not different universes where different events occur. Because if the second pedestrian, moving away from Andromeda, turns around and follows the first pedestrian, their perspective on events in space will be conditionally similar to the first pedestrian's. Conditionally because complete synchronization is obviously impossible. But again, not because the universes are different. I think you already understand where this is heading. Yes, looking at the situation from the opposite side, it turns out that from the perspective of extraterrestrials in the Andromeda Galaxy, the same will happen in relation to us. From their point of view, you might exist yesterday for some of them and tomorrow for others. I'll ask this question again: what would the universe look like if this were possible? The special theory of relativity tells us that there are infinitely many planes of simultaneity passing through any given point in spacetime. And for each point in space, there are different or very different sets of simultaneous events, different planes of simultaneity. Thus, even the slightest movement of your head changes the perceived present moment in the universe for you. It becomes even more absurd when you realize that spaces of present moments differ for your head, your hands, your legs, and your body. Okay, I know I've been going on, so here's the thing. What would such a universe look like? If somehow we could fly beyond the boundaries of space and, looking back, survey it, according to the special theory of relativity, we would see an unchanging four-dimensional block where time exists as another spatial coordinate. We would understand that within such a model, a block universe model, to speak of now is the same as speaking of here, because any present moment is real and exists on one of the sections of this block. Scientist and mathematician Rudy Rucker wrote,
As it turns out, it is actually impossible to find any objective and universally acceptable definition of the entire space taken at the moment. This follows from Einstein's special theory of relativity. Thus, the idea of a blocky universe is more than an attractive metaphysical theory. This is a well-established scientific fact.
Interestingly, when Einstein first published his paper on the special theory of relativity, he did not claim that time should be considered the fourth dimension of the universe. It was his former teacher from Zurich, Hermann Minkowski, who first made the groundbreaking connections between space and time. Minkowski, who reportedly once referred to Einstein as a lazy dog during his student years, was the one who transformed Einstein's theory into a geometric framework. In 1908, building on his earlier work, Minkowski grandly announced,
The views of space and time, which I wish to lay before you, have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth, space by itself, and time by itself, are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality.
Of course, we cannot truly visualize or represent a four-dimensional block. However, for clarity, we can simplify it by neglecting one spatial dimension, as illustrated here. With this representation, it becomes easier to understand the concept of the plane of simultaneity. Let's consider a more radical scenario. Imagine an Earthling and an alien being from a galaxy not 2.5 million light-years away like Andromeda, but 10 billion light-years away. If the alien and the human are stationary relative to each other, their clocks run synchronously, and the present moment for both lies on the same slice of the universe block. However, if the alien starts moving away from Earth, their clocks will desynchronize because, as a reminder, time slows down for moving objects. Thus, the alien's plane of simultaneity regarding Earth will tilt towards the past. Suppose the aliens in this distant galaxy are not moving much faster than humans, the angle of tilt would be small. But over a distance of 10 billion light-years, even a small angle would result in a huge time difference, making the present moment on Earth, from the alien's perspective, a point in the 19th century. According to the special theory of relativity, this moment is just as real as the one you are experiencing now. By adjusting the alien's speed, direction of movement, and distance from Earth, we can make any moment in time the present, be it from the year 1000 or the year 3000. This is one reason why faster-than-light travel seems highly improbable, as it would lead to not only spatial but also temporal displacements. You could easily travel to Andromeda and then to your own yesterday, causing paradoxes. But if you think that's all there is, this is actually just the beginning. To delve into the main puzzle of this discussion and better understand it, we need to talk about how people perceive time. Humans seem to have developed the ability to understand the concept of time using the same mechanisms designed for understanding space. In other words, at the most basic level, the brain may not differentiate between space and time. Renowned Swiss psychologist Jean Piaget saw parallels between psychology and physics. This might sound far-fetched, but bear with me. Piaget revolutionized the field of psychology and development by explaining how children come to understand abstract concepts such as quantity, space, and time. He believed in a profound connection between a child's innate understanding of time's relativity and Einstein's theory of relativity. To understand how children perceive time, Piaget asked them to perform various simple tasks. In one such task, he used two toy snakes that crawled along parallel paths for several seconds. For example, a blue and a red snake would start moving from the same position at the same time and stop simultaneously, but the blue snake would travel further because it moved faster. Children aged 5 to 6 would incorrectly report that the snake that traveled a greater distance stopped later. The parallel with the theory of relativity is this: children intuitively understand that for a faster-moving object, time stretches out. This suggests an innate grasp of the concept of spacetime. Of course, this is a bold statement. Nevertheless, Einstein himself reportedly remarked that Piaget's ideas were so simple that only a genius could have come up with them. Let's explore how the adult brain handles this concept. Imagine two light bulbs flashing alternately for short intervals of 8 seconds. In an early study, it was found that when the bulbs were 20, 40, and 80 centimeters apart, the average perceived interval between flashes was 6.5, 7.5, and 8.5 seconds, respectively, even though the actual interval was always 8 seconds. This phenomenon, known as the Kappa effect, has been demonstrated in various ways and shows that the distance between two events significantly affects our perception of the time interval between them. Once again, it seems the brain fundamentally links space and time. Think about how you visualize chronology. Arrange the years 2022, 2023, and 2024 in chronological order in your mind. Done? Your brain likely didn't attempt to do this any other way than by arranging 3 objects, 3 numbers, and a spatial sequence within mental space. Essentially, it operates using spatial categories. It's difficult to imagine doing this differently unless you mentally relive these 3 years. But most importantly, I bet you arranged them from left to right. If not, you're in the minority. Chronology in our minds almost always looks like a horizontal arrow pointing left to right. This feels natural, but why? We could represent the timeline in any direction. Since we use space to denote time, why not right to left? Or even better, bottom to top? Isn't that more intuitive for moving forward in time? Yet people usually visualize it this way. There have been many attempts to explain why the brain often uses this left-to-right mental timeline. Dean Bonamano suggests it might again be due to how our brain is wired. For instance, in an experiment where participants had to compare the duration of notes to a given standard and distinguish shorter sounds from longer ones, an interesting pattern emerged. The task's effectiveness depended on button placement. People performed better when they could use their left index finger for shorter intervals and their right index finger for longer intervals, not the other way around. This indicates it's more natural for humans to respond to short signals with their left hand and long signals with their right. Bonamano writes that it's as if the mental timeline in our neural circuits is oriented left to right. Further evidence of a mental timeline comes from the lab of cognitive psychologist Lera Boroditsky. People who have suffered a stroke affecting the right parietal lobe often exhibit left-side neglect, meaning they don't perceive objects on their left side. For example, they might not eat food from the left side of their plate or wash the left side of their face. Boroditsky and her colleagues showed that these patients also struggle to place past and future events on a mental timeline, leading to difficulties recalling the temporal context of events. Additionally, when talking about time, we frequently use spatial adjectives and adverbs, looking ahead, looking back, short life, long time, and so on. Spatial metaphors are commonly used to describe time and rarely the other way around. Except for phrases like "I live half an hour away," it's hard to think of any. This occurs in all languages worldwide. Dean Bonamano writes, overall we do not yet understand how neurons in the hippocampus, or anywhere else in the brain, measure, represent, or store spatial and temporal magnitudes. Yet, based on linguistic, psychophysical, and neurophysiological evidence, it is clear that space and time are indeed intertwined within our neural circuits. Life in general, and humans in particular, can move along spatial axes in both directions. You can go forward, backward, left, right, up, and down. However, movement along the time axis only happens in one direction. At least, this is what we know from our conscious experience. Yes, we can regulate the speed of our movement through time, but not the direction. For us, time always moves forward and never backward. The fundamental laws of physics do not explain why it seems to us that time flows forward. Newton's and Einstein's equations, Maxwell's equations describing the laws of electricity and magnetism, and Schrödinger's quantum equation do not depend on whether events occur in a forward or reverse order. They do not specify a unique present moment. Despite these compelling arguments that suggest we live in a block universe, we must acknowledge that the laws of physics cannot explain the most obvious human observation. The present moment is distinct from all other moments and time passes. Even Einstein apparently adhered to the block universe concept and was troubled by this discrepancy between our perceptions and the modern understanding of physical laws. Philosopher Rudolf Carnap, recounting a conversation with Einstein, wrote, "Once Einstein said that the problem of the now worried him seriously. He explained that the experience of the now means something special for man, something essentially different from the past and the future, but that this important difference does not and cannot occur within physics. That this experience cannot be grasped by science seemed to him a matter of painful but inevitable resignation. An analogy that comes to mind is this: it's as if the universe with all its events were a vinyl record, and our consciousness were the needle of the record player. But this analogy is absurd because consciousness is part of the universe, and in this analogy, it should be part of the record, not something outside of it. The inability to reconcile the idea of a block universe with the sensation of the flow of time is such a profound problem that many physicists and philosophers believe the only way to solve it, as strange as it sounds, is to acknowledge that the sensation of the passage of time is an illusion. But what does that even mean? And how can it possibly be illusory? In my opinion, the greatest outstanding riddle concerns the glaring mismatch between physical time and subjective or psychological time. The overwhelming impression of a flowing, moving time, perhaps acquired through a mental backdoor, is a very deep mystery. Is it connected with quantum processes in the brain? Does it reflect an objectively real quantity of time out there in the world of material objects that we have simply overlooked? Or will the flow of time be proved all to be entirely a mental construct, an illusion or a confusion, after all? Yes, the sensation of the flow of time is indeed a mental construct. At the very least, it's a construct because we perceive the surrounding world from inside our heads. Just like vision, which we discussed earlier, is a mental construct. So are sounds and smells. These are illusions in the sense that they don't exist in the external world but have adaptive significance because they correlate with real physical phenomena, the length of an electromagnetic wave, specific sets of sound waves, or the chemical structure of molecules. For example, there is no actual blue color in the objective world. Blue is an illusion caused by electromagnetic radiation with a wavelength of 470 nanometers. In the objective world, there are no unpleasant odors, but there are sulfur molecules, which the brain interprets as the smell of rotten food. Any such illusion has adaptive value because it strictly correlates with something that really exists. As we see, it literally has no equivalent in the physical world. This makes it not just an illusion in some sense, but an illusion in the most literal sense of the word. In the block universe, our sensation of the flow of time is more comparable to the hallucinations of a schizophrenic, something that exists only within us and not in the real world. Contemporary philosopher Craig Callender writes, "The equations of physics do not tell us which events are occurring right now. They are like a map without the you are here symbol. The present moment does not exist in them, and therefore neither does the flow of time." And resolving this puzzle, the puzzle of uniting human perception with the laws of nature, is an extraordinarily complex task that lies at the intersection of physics, neurobiology, psychology, and philosophy. Is science unable to grasp a fundamental quality of time that the human mind embraces as readily as the lungs take in air, or does the human mind impose on time a quality of its own making, one that is artificial and that hence does not show up in the laws of physics? If you were to ask me this question during the working day, I'd side with the latter perspective, but by nightfall, when critical thought eases into the ordinary routines of life, it's hard to maintain full resistance to the former viewpoint. Brian Greene, a theoretical physicist, one of the most prominent string theorists. At the beginning of the video, it was mentioned that the structure of the universe has left its mark on the construction of the human brain. And indeed, as we have seen by analogy with the theory of relativity, the brain spatializes time. However, Dean Bonamano proposes considering the reverse perspective. He asks, are we inclined towards one or another interpretation of the laws of physics because the brain interprets time in a certain way? So, the laws of physics and the human brain are not independent of each other. It's not just that brain function is based on physical laws, but also that our interpretation of physical laws is connected to how the brain operates. To put it in simpler terms, could the structure of our spatially oriented brain influence how we see a block universe when we look at equations? To what extent is the brain impartial in its interpretations? This leads to a situation where humans themselves do not fit into the physical world picture they have created. However, you must understand one very important thing. The laws of physics do not directly lead to the unequivocal conclusion that we live in a four-dimensional block universe. The block universe idea is undoubtedly the most satisfactory interpretation, an attempt to straightforwardly explain what the equations of special and general relativity suggest. This interpretation is widely accepted by many respected scientists. Nevertheless, it remains just an interpretation. In physics, the quest continues to create a unified theory capable of explaining the nature of time. And as is appropriate in science, there is no unanimous agreement. Among the community of scientists who adhere to the block universe concept, some are making attempts to explain the sensation of the passage of time. For instance, David Deutsch, in his book The Fabric of Reality, discussing our experience of time in a block multiverse, writes, objectively, the present does not exist. We do not feel that time is passing or passing. We feel the difference between our present sensations and our present memories of past sensations. Earlier I thought I understood well what he meant, but the more I thought about it, the less confident I became. Or, for example, Brian Greene, who has already been mentioned, also gives his comment where he tries to combine the sense of the flow of time with the block universe. Each moment in spacetime, each time slice, is like one of the still frames in a film to the you who is in any such moment. It is the now, it is the moment you experience at that moment. And it always will be. Moreover, within each individual slice, your thoughts and memories are sufficiently rich to yield a sense that time has continuously flowed to that moment. This feeling, this sensation that time is flowing, doesn't require previous moments, previous frames, to be sequentially eliminated. It's up to you to judge, but in my view, all this doesn't really seem like an answer, but rather an attempt to evade it. Perhaps the clash of different ideas will one day help us better understand the nature of time. Or perhaps it's even more uncharted and strange than we currently think.